Here we have a calculus problem on finding critical numbers of a function. Okay, there is a function given over here, that is f of x equals to sine square of 2x, and we have to find critical numbers in this interval 0 comma pi, the closed interval. Okay, whenever I want to find critical numbers for a function, what I have to do is I have to find the first derivative of the function, and then it has to be equated to 0 and solve for x. Okay, now let me take the given function as it is, that is f of x equals to sine square of 2x. Okay, so before I find derivative, so what I'm going to do is I'm going to write this exponent 2 as exponent for the complete stuff, that is sine of 2x the whole square. Okay, now I'm going to find the derivative of this function, that is f prime of x. Okay, when I find derivative of the given function, first I have to do derivative for this exponent using the power rule of derivative. What is the power rule of derivative? So we have to bring this exponent 2 in front of this and subtract 1 from the exponent. Then I'm getting 2 times sine of 2x whole to the power of. So when I subtract 1 from this 2, I'm just getting exponent 1. So whenever there is the exponent 1, we don't have to mention. Okay, so far I have completed derivative only for the exponent 2 over here. By chain rule, I have to do derivative for this sine. So when I do derivative for the sine of 2x, I'll be getting cosine of 2x. Again, by chain rule, I have to do further derivative of this 2x. So here 2 is a constant multiplied by the variable x. When I do derivative for this 2x, I have to keep the constant as it is. When I find the derivative of this x with respect to x, it will just become 1. So 2 times 1 is 2. So finally, the derivative of this 2x is just 2. Okay, now f prime of x equals to, so we can write these 2 in front of everything because all of them are in multiplication. So then we get 2 times sine of 2x times cosine of 2x. Okay, now let me consider the double angle identity in trigonometry. That is like whenever we have an expression in the form that is 2 times sine theta times cosine theta, so that is equal to sine of 2 theta. Okay, so now just consider the expression we have over here. So this expression, particularly the one which I circled, is exactly in this form. Okay, so if 2 times sine theta cosine theta is equal to sine of 2 theta, then what do we have to write for this expression? For that, we have to write this expression over here so that we can compare this one and this one easily, and we'll get the simplified form for this expression. Okay, now let me write this expression over here. That is 2 times sine of 2x times cosine of 2x. Okay, now let's compare this one and this one. So here we have 2, here we have 2. At the place of theta, what do we have? We have 2x. So here we have theta, here we have 2x. So on the right side, so in this sine 2 theta, so we have to write 2x at the place of theta. Okay, let me do it. Sine of 2 times. So at the place of theta, we have to write 2x. So now I'm getting sine of 2 times 2x is 4x. So the simplified form of this expression is sine of 4x. Okay, now let me plug in the stuff over here. So f prime of x equals to, so 2 times for this expression, we know that sine of 4x. So for this one, we can write sine of 4x. Okay, now I got the first derivative of the given function. Okay, to get the critical number, what I need to do is I have to equate the first derivative, that is f prime of x to 0. So let me equate f prime of x to 0. Then I'm getting 2 times sine of 4x equals to 0. So now to get of this 2, I divide both sides by 2. So when I do so, this 2 will cancel out. I'm getting sine of 4x equals to 0 over 2 is 0. Okay, now let me continue on the next page. This is the last step we have had on the previous page. Okay, now in this equation, I have to solve for x. So that will give critical numbers for the given function. Okay, here we have sine of 4x equals to 0. Okay, so here 4x represents angle. Okay, so for what angle measure, we get the value 0 for sine. So that's what we have to find over here. So now let's consider the 4 quadrants and the angle measures. Okay, let me draw. Here I have drawn the 4 quadrants. This is quadrant 1 and quadrant 2, and this is quadrant 3, and this is quadrant 4. And here we have 0, and here we have pi over 2 radians angle. Here we have pi radians. Here we have 3 pi over 2 radians. Again, when I read this portion, it will be 2 pi radians. Okay, now already we know that the value of sine will be 0 at these 2 positions. That is sine 0 equals to 0, and also sine pi is also 0. Okay, let me start from 0. So when I am at 0, so the value of sine is 0. That is sine 0 is equal to 0. Now, when I reach pi radians, the angle measure, that is sine pi is equal to 0. Again, I am moving, and when I reach position 2 pi, that is sine 2 pi equals to 0. Again, I am moving. When I reach this position here, it will be 3 pi, that is sine 3 pi equals to 0. Again, I am moving. When I reach this position, it will be 4 pi. Again, if I move and if I reach this position 5 pi, so when I reach this position 6 pi, in this way. So like, so sine is 0 when the angle measure is 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. So for all these angle measures, I mean, for multiples of pi, so the value of sine will be 0. But what angle measure do we have over here? It's 4x. So at the place of 4x, if I have 0, then it will be sine 0, sine 0 is equal to 0. At the place of 4x, if I have pi, then sine pi is also 0. So these are the possible angle measures we have for 4x. That is, 4x can be equal to 0 or pi or 2 pi or 3 pi or 4 pi or 5 pi. But our aim is to get the value of x. And also, one more thing we have to remember, there is a domain given over here. That is, we have to find the critical number in the given interval, in the closed interval, that is 0, pi. Okay, so and you may have a question. So we have to find critical number in the interval 0, pi. Then why should I take up to 5 pi? So actually, this is the interval given for the values of x. But here we got the values for 4x. So to get the value of x, I have to divide everything by 4. So I divide this one by 4. On the right side, each value has to be divided by 4. Okay, let me finish writing. Okay, so here 4 will cancel out. I'm getting x equals to, when I divide 0 by 4, it's 0. Then I'm getting pi over 4. And when I simplify this one, 2 goes into 2 one times, 2 goes into 4 twice. Then I'm getting pi over 2. Then 3 pi over 4. Then this 4 will cancel out. I'm getting pi. So now I don't have to consider the angle measures that we have after this stage, because now we have reached pi. So the domain is 0, pi. So now we started from 0 and we end up with pi. So we should not consider the angle measures we have after pi. So okay, so when when sine of 4x equals to 0, the values we get for x are 0, pi over 4, pi over 2, 3 pi over 4, pi. Actually, we got all these values for x when I equated the first derivative to 0. So all these values of x are called critical numbers. So also we have to do one more check. So once we get the critical numbers by equating the first derivative to 0, and we should not forget to do one more check. That is, let's consider the final step of the f prime of x, the first derivative. So in this step, we have to make sure whether there is any real value of x for which f prime of x becomes undefined. So for example, if I plug in any angle measure over here, so is there any chance for this f prime of x becomes undefined? No, there is no chance at all. So because already we know that the value of sine theta, the greatest value of sine theta is 1. So the smallest value of sine theta is -1. So always the value of sine theta will oscillate between from -1 to +1. So it will never become undefined or infinity. So we can plug in any angle measure for x. So the f prime of x will never become undefined. So in case, and you may have a question, for example, if there is any value of x for which f prime of x becomes undefined, what do we have to do? So the value of x for which the first derivative becomes 0 should also be considered as a critical number. So if there is any real value of x for which f prime of x becomes undefined, so that real value of x should be considered as a critical number along with the numbers what we got by equating the first derivative to 0. But here for any real value of x, f prime of x, I mean the first derivative will never become undefined. So we won't get any critical number by this check. So now we have to consider only the values of x we got by equating the first derivative to 0. There is 0, pi over 4, pi over 2, 3 pi over 4, pi. So these are all the critical numbers for the given function.